And now some vocabulary. Materials can be classified as conductors or insulators. A conductor is something that lets electricity flow through it. An insulator is the opposite. An insulator does not let electricity flow. Here are some examples of conductors and insulators. Notice how the conductors are pretty much all metal. With a few exceptions, water can be a good conductor. This is why you don't want to drop the hairdryer in the bathtub. You can electrocute yourself as the electricity is conducted through the water. But mostly metals are conductors. Notice how the insulators are mostly nonmetals. When you plug something into the wall, here's what's going on inside the cord. On the outside, there's plastic or rubber, which is a great insulator. But inside is metal, which is a good conductor. You need to have conductors inside so that they can carry the electrical current. However, you want to have insulators on the outside so that you don't get electrocuted when you touch it. One way to produce an electrical charge is through a battery. A battery has two sides. The cathode is the positive side, and the anode is the negative side. This causes a potential difference between the negative and positive terminals of the battery. You may recall from our last unit on energy that the battery contains a form of potential energy called chemical energy. So these chemicals inside create this potential difference between the material at the anode or negative side and cathode or positive side. When a closed circuit is created between the negative and positive sides of the battery, the electrons can travel from the anode to the cathode. You'll notice that we've used wires to connect one end of the battery to the other in a closed loop called a circuit. The potential difference between the negative and positive battery terminals, or the two sides of the wall outlet, notice they're also positive and negative, is called voltage, and the unit is the volt. So when we describe the voltage, we're really talking about the potential energy contained in the battery or contained in that wall outlet. The potential difference between the negative and positive sides is the voltage. You might think of voltage as electrical potential energy. Just like this water faucet, there's a lot of potential energy in the water. Right now, nothing's coming out, but when you turn the handle on, that water's there. It has the potential to start flowing, and as soon as you turn the handle, there it goes. Look at these two batteries. They're both marked with a voltage. The one on the left says 9 volts, the one on the right says 4.5 volts. Which one has the potential to provide more electrical current? Well, obviously it's the battery on the left because it has more voltage in it. Current is defined as the rate at which a charge passes a given point. Look at these two wires. They both have current flowing through them, represented by the moving dots. The dots are charges, or more specifically electrons, negative charges. Well, the red wire has more current because there's more electrons flowing through it. The blue wire has a smaller current. You can see there's fewer electrons moving through it. Sometimes there can be too much current for that wire or for that conductor. It can get too hot and even start a fire. If you could count how many charges pass each second, that's the current. The unit is the ampere, or most people just shorten it to amp. So if the scientists could watch and literally count those electrons, 1, 2, 3, 4, he would be counting the current. But since we can't see electrons, we have to use a machine to do that for us. Two different types of electric current. There's direct current, where the charges always flow in one direction. This is used in batteries. And alternating current. In alternating current, the charges switch from flowing in one direction to flowing in the reverse direction. This is what you have in your wall outlets coming into your home through the power lines. Alternating current is able to travel a lot farther, so it can get all the way from wherever the power plant is located to your town and to your house. Direct current is better for small things like a flashlight because it can't travel quite as far without losing some of its efficiency. If you look at the two pictures, in the direct current, see how the electrons are all just flowing in one direction? I think of it as they're just going directly where they're supposed to go. So if your mom said go directly to your room, you're in really big trouble, you probably should go straight there. That's what the electrons are doing. They're just going straight there. But look at the alternating current. The electrons go up, down. Or if I look here, right, left, or down, up, down, up. So they're alternating or reversing. Resistance is the opposition to the flow of electric charge. The unit is the ohm, which is that little upside down horseshoe thing. If you imagine that you're on a sports team and you're playing against another team, they are your opponent. So opposition is like your opponent, the one you're fighting against, the one you're trying to beat. So we need to try to beat resistance in order to have electric current flowing. Good conductors have a low resistance. Poor conductors have a high resistance. If you look at the first picture, that would be what's going on inside the insulator. The voltage is trying to have this potential energy flow through the material, but look at the little electrons, the yellow circles with the negative sign in them. That little hand is stopping them. It's saying like, whoa, no, you are not moving through me. No electrons. That's your insulator. Now your conductor is more like the picture on the right. Look at the little blue dots representing your electrons, the negative charges. They're able to flow right through there. The great big circles are the nucleus of the atoms, but you'll notice the electrons can move right past the nucleus, no problem. There's very low resistance. So that would be like a copper wire, something that has low resistance and makes a good conductor. Now there is something called a semiconductor. A semiconductor is just something that's in between. A semiconductor is kind of a medium resistance. Now close the window with this video so you can finish the lesson on Nearpod.